Okay, I'm not far enough back. RCA KCS-47 Resurrection. Holy, something just arced. I think we might have tin whiskers in our whiff pot. RCA KCS-47, the Bill Cahill Misery Special. Seriously, go on antique radio forums and look this set up. That guy had like a 10-year-long, 30-page, 15-poster or more a page thread of just him having problem after problem with one of these things. You've seen this set already in the Zenith Porthole and Brighteners video, whatever the heck I end up titling it. It's not edited yet, but it's filmed, and now I'm filming this. I'm going to try to do a resurrection on this TV. I'm going to power it up on a Variac and see what it does. We're doing something a little bit different than last time. I've decided I want the chassis on top of the cabinet when I Variac it. So, back when I was doing my RCA 21CT55 prior to this channel existing, I made up this nice little speaker extension cable for servicing. I've got this nice octal yoke connector extension cable that came with a test jig I have for color sets. That'll work perfect for this. I'm going to use a brightener to extend the CRT heater. I really should make an extension cable for this style of CRT base, but I'm not going to get to that yet. One day I will, definitely, though. And there's no HV extension because I don't really expect this set to power up and give me HV. If by some miracle it does have high voltage right here, I'll stick my probe on, take a measurement, maybe draw some finger arcs, and then construct a really dangerous HV extension cable. This particular set is missing the lead it needs to adequately connect the high voltage terminal on the chassis to the metal cone picture tube, so I'm going to have to whip up something incredibly haphazard and sketchy if we even get to that point. This set I paid less than a decent fast food meal at Portillo's for as a CRT donor for my porthole, so I literally could care less whether I make this thing work or not, and I have no intention of keeping it. And I'm probably going to end up giving it away for less than what the tubes are worth, so I'm going to end up pulling all the tubes that are worth more than $1 a piece, getting rid of it to whoever will take it. This might even end up a fish tanker special when we're done. It just needs to go within the next couple months. Since we're all set up and ready to go, aside from the Variac, one Variac, let's turn it down to about 30 or 40 volts. And cheater cord, where art thou? There you are. Okay, one cheater cord. We've already verified that the power knob is in the on position. She's running at 40 volts. And she's drawing about 30 watts. Let's just let her sit and cook until she runs or burns. And I'm going to be doing like 2 or 3 other things while I film this, so I'm probably going to, instead of giving myself lots and lots of long 10-minute or long 8-minute shots of nothing happening that I need to do fast motion on, I'm probably just going to click the camera on and record whenever I turn up the voltage or anything interesting happens. Because that'll mean less editing for me later on. Okay, wattage is already lowered to 18 from about 3 minutes of sitting. So we're going to turn it up from 30 volts on the Variac to 40 volts on the Variac. And I'm just going to resolder this remote dial light socket mid-air with only 2 hands, but actually needing 3 to do this right. Cue Saber Dance or some other circus theme music. I love it when I'm gripping a piece of metal that I'm soldering and it gets warm enough to start just ever so slightly burning my fingers. That's just great. Okay, so light bulb is in. She's still only drawing 18 watts at 40 volts. Okay, let's give her another 10 volts. I'm looking forward to watching this set either smoke or produce a picture. I'm unlikely to recap this set, and if I do recap it, I'm not going to use my good new capacitors that I've bought from Mauser. I'm going to use my old crappy capacitors that broke college student me yanked out of old 90s solid state televisions that were at the garbage circa 2010 to 2015. I'm still telezoom thermomaticking it. I wonder if I even got the soldering I did in that shot. God only knows. Okay, so it's up to 25.8-ish watts. I just let it sit for a little while longer and see what happens. Even though this is one of the worst early post-war RCA chassis circuit design-wise, I'm going to be pointlessly optimistic and just have a high voltage probe sitting around here so I can measure the high voltage whenever. We'll see how that goes. Okay, we're at 50 volts according to the Variac dial and 50 volts according to the kilowatt, and about 26 watts of power consumption. Let's turn it up to 60 and see what happens. 37 watts. I'm definitely not going to have high voltage to like 70 or 80 volts. If I get it at all. I doubt I'm going to get high voltage. We'll let it sit and spin at that voltage and come back. Okay, we're at 37.7 watts after a very long time sitting at that voltage. Let's crank it up to 70 and see what we get. Up to 56, 59. Analytics doing. Still pretty cool. That works. And we're also busy cleaning a predicted tandem cable, the last dirty one I've got. Debating whether I want to go to the effort of switching this cable with the one on my keeper set. I tend to think no because of that splotch of super glue I must have accidentally dripped over the dirt that was on it that is now encasing the dirt onto it. Goof Off does dissolve super glue, but when super glue is cured it takes forever. Okay, it's been sitting at about 61 watts all this time. Nothing's really getting hot, except maybe the power rectifier tube and some of the other tubes, which is normal. We're at 70 volts. Let's go up to 80 and see what happens. Sounds like the vertical sweep might be running, but I'm not sure. That or I'm hearing a paper capacitor melt and hiss. That would be exciting. 89 watts. What's the voltage? About 81 volts. That doesn't seem unreasonable for what I'm dealing with. Am I going to get my smoke action? Or my raster? Do something exciting, damn it. It'd even be fun if one of those electrolytics came and blasted a hole right through my skull. Nothing makes you feel more alive than just about dying. Or being on your way to dying. Then you know you were alive. Okay, we're up to 91-ish volts and about 120 watts. Holy crap! My meter tells me that there is 8 kilovolts of high voltage right now. That's pretty cool. Well, since nothing's overheating yet, that sounded like there was some life from the Iaf system. That's kind of cool. Well, I'm going to hook my smartphone up to my Agile modulator and see if I can get any audio to pass through. there's no obvious reception. Take it up to 100 volts, 99.7 and 148 watts, and we're at 10 kilovolts of high voltage. This sucker's actually going to have high voltage somehow. Great, now I gotta wire up a... Okay, so we had a solid 10 kilovolts of HV earlier, and we currently do have it. Let me see if it makes it to the bell of the tube. Oh yeah, it made it! My haphazard, improvised, no one gave me a high voltage lead, so I made one. Lead is actually working. That's pretty cool. Now I need to work on adjusting the ion trap on this set. So to do that, I'm going to need to move this chassis slow and gently. Open a door so that I can actually see the picture tube. No, hey, there's faint glow on the screen. Can you guys see it? It's right around where the power cord is. Let me dim the room lights for a sec. Right there. You have some faint high voltage glow. That's pretty cool. So I need my service mirror wherever the heck I left it. And I need to adjust the ion trap for maximum ice-holdingly bright dimness. Where the salmon is my service mirror? Because you got legs doesn't mean you can walk around. It's hiding next to my camera tripod. The last place I would look. Okay. One service mirror that I can sort of look at while playing with the ion trap. I got no clue what constitutes brightest. Well, we have some ion trap action. I like how the dial light's flickering like we might have an electrolytic that's trying to short. We clearly have no vertical deflection. Do we have any brightness? You're the brightness control and you're maxed. Well, the under chassis caps are puking their guts. That's nice to see. There's definitely no vertical deflection, and she's pretty dim, but you can see there is a little bit of light on the screen there. Okay, so now that we know that it's not dead, you know, before I settle on that being the optimal adjustment of the ion trap, I haven't tried it 180 degrees out. Back up if you'll just cooperate with me. Oh, hello. Oh, now that's getting to be more like it, eh? Now that's a nice focused deflection line. That clearly shows we have no vertical deflection. Just turn the brightness down to the minimum setting where the line is reasonably visible to my eyes in a lit room. Any higher than that and you'll burn the line into the phosphor and there'll be a permanent dark line in the phosphor. So yeah, keep it dim if you've got collapsed raster. Okay, so now that we know that this isn't a complete lost cause, I'm going to turn it off and look up the schematic for this thing and see what it shows about the vertical and what I can learn checking the vertical out and see if I can give it a minimal recap to get a picture on the screen. Okay, so we got the schematic for it up. We're going to try the brute force method of checking where the problem in the vertical deflection is. What we're going to do is we're going to short pin 5, the grid of the 6K6 vertical output tube, to pin 7, the hot lead of the heater. Basically, the heater is about the same frequency as what the vertical circuit is supposed to be on this set, within about 1% accuracy, which is pretty good. Basically, it should be close in amplitude to what the grid is expecting as a drive signal, so if we have bad signal to the grid, this will theoretically give us good signal to the grid. I'm just going to slowly ramp the variac up to 100 volts. Hey, that's giving us some deflection. It's not very much, but it's some. That could just be that the drive waveform that is being created by the heater circuit isn't enough for this particular application. Or it could be that the output tube's weak. I'm bored enough that I'm going to try something. This is a 6K6 for the vertical stage, and I believe this is the audio output stage 6K6. I'm going to pull the audio output 6K6 swap over the vertical and audio output 6K6s and see what we get. Tube's warming back up after a brief moment out of the set, and we're getting about the same thing. So that tells us that we're definitely not getting good drive. Here's another idea. Let's try pin 5 of the 6J5. This thing uses a 6J5. That's different. Pretty sure that's this guy here. So 1, 2, 3. So 5 would be there, so I should be able to disconnect this and hook it up over here. And let me disconnect it again. Okay, that tells us things. It tells us the 6J5 is not oscillating, and it also tells us that there are sufficient cap issues in the vertical output to make it not work well. That 50 microfarad on the cathode could be a problem. The 20 on the output transformer could also be a problem. And the vertical LIN pot could be open, and that could be causing us issues. Or it could have tin whiskers or something. Here's the vertical LIN pot. Does adjusting it. It has a little bit of an effect. Okay, I'm going to grab that junk box of capacitors. I'm going to grab my capacitor tester over here and go through the vertical stage paper capacitors and see if I can convince this sucker to oscillate and to create a full raster on its own. If it does that, then next up on the dock it'll be trying to convince it to pass signal. But just having a raster on it makes it a more saleable set. Okay, so we disconnected 2 capacitors here. This one's the vertical output grid coupling cap, and this other one is a capacitor that goes to ground for timing reasons. We're going to check those 2 capacitors for leakage and capacitance. We want to do this capacitor on the grid first because if it's bad, we'll have positive grid voltage, which will use up that vertical output tube a lot faster than it normally would fail. Okay, capacitance is a little bit on the high side. This is, I think, 2 here and 3 there. Or is that free from? It's not terrible. Let's see about leakage. It's a little bit leaky at 25 volts. It's a little bit more leaky at 150. Oh, it was leaking through the power cord a little bit. That's interesting. Just shows how sensitive this tester is, that it can detect mega ohm level leakages. That is not great at 250 volts, but it's potentially usable. It's not really opening at 350 nearly as much as I would want from a good capacitor, and at 450 it's positively miserable. And this is a 600 volt rated cap, so yeah, it goes bye-bye. So, I have no clue what's in frame, and now I'm kicking the thing, which isn't helping life at all. So this is my big box of junk capacitors that I don't know why I keep. Maybe because I knew one day I would be doing YouTube resurrections and I would need garbage parts for garbage sets. I need a 0.22 microfarad cap. Oh, you 2 are 0.1s. And there's a 103. This terrible kludge that I probably made for some set and then ripped back out of it is, I believe, a 0.22, and all the caps in here are rated for 630 volts, so if this tests okay on the cap checker, this will functionally work for the vertical cap. Tests fine on leakage. Capacitance is pretty much in the right ballpark. This is good enough. We're going to put it in place of that one cap. Before I go about installing it, there's a, looks like a 1 kilovolt .047. Schematic definitely calls it a .047, and the banding says it's a kilovolt cap. Let's see how that cap tests while we're here. Yeah, that bumblebee is testing. It's barely opening the ion capacitance, and it's high in value, so it's probably leaky. Oh yeah, it's leaking at 50 volts. It's pretty much shorted at 150 volts. And yeah, that's... So, this bumblebee cap in here on the chassis that I think you could see me pointing at is shot, so now I need a .047. You know, best way to do that, since it's basically a .05, would be to get two 630 volt .1s and put them in series. That would probably work as a replacement for it. And I do have 2.1 caps here. Let's see if the 2.1 caps I have are... These are new ones I installed in something and clipped back out. Probably because it was something that ended up getting scrapped. That's an interesting test result. Why do you test high? That makes no sense. Why some caps are in my junk box? Because they deserve to be. Okay, so we replaced these two capacitors together because they both tied to the same terminal strip on one end, and both tested bad, and both are potential culprits for this set not working. Well, there's so much more that could be making it not work. I think I'll also get my multimeter out, so this time when I power it up I can probe around a few places on the schematic and look for voltages. I won't be learning very much because this is an early SAM schematic that doesn't list all the pertinent voltages on the tubes on the schematic itself. It has a separate chart that's really annoying to reference and unergonomic. But I can check B+ into the circuit in a couple of key places and see how it's loading down based on capacitors and other parts of the circuit. It'll give me a chassis ground right there. Hook the power up to this thing. And let's check the wattage. Let's just crank it up to about 100 volts. There we go. I'm also going to have my... Okay, so we've got no deflection still. Let's just see if I clip this onto the place where I was before. Yeah, we get some deflection back. What about right here? A little bit. So there should be 370 volts B+ to the vertical output transformer, which is the red lead. Comes off of pins 3 and 4, which are there. I hear unhappy electronic sounds. That doesn't please me. There's supposed to be a resistor capacitor network across it. It's a 220k ohm and a .022 cap. Theoretically that should be 370, and it is 286. That's not great, but there's probably some loading on the B+. Let's check the plate of the vertical output tube. 281, so, you know, if I put a nice oscillator signal going into it and then check that. Nope, it's still about the same. That's good to know. Alright, let's check the vertical oscillator tube itself and see what it has to say. Its plate is pin 3, and it's also being fed from that 370 volt B+ rail. Yeah, let's check pin 3 on that thing. This guy here. And that's only 3 volts DC. That tells me the oscillator's not working. So the height control is one thing that could be a problem there. You know, I'm going to try rotating the height control while I'm here, because I can't read the captions. Ah, there it is. Height. Hey, wiggling the height control got me some stuff. Let me, hey! See that? I just disconnected the heater signal that I was feeding into the grids of the vertical stage, and now the vertical is actually oscillating on its own. I'm so proud of you. It's trying, but there's clearly issues. I am going to make a series of educated guesses. I want to see what the voltage is on the height control itself right now. The height control is U. It's 147, and the other one is 140. That's something. So I'm going to say that the 5 microfarad cap on the height control might be dragging the 370 volt B plus down a bit. There's supposed to be a 220K that feeds this potentiometer from the wiper, and wiper goes to, I think, here. And that's 148 volts there. There ought to be a resistor somewhere visible. Of course, it's not visible. Okay, I'm going to disconnect that 5 microfarad cap, which I believe is this guy right here. Yeah, this is a tubular lytic. Okay, no clue where I stopped, but we have insufficient plate voltage, I believe, going to our vertical oscillator, and I believe this 5 microfarad tubular electrolytic is bad, and that my multimeter wants me to place it on the ground without any care. Nope, definitely not. Let's see here. I'm going to disconnect the negative end of this cap because reasons. 5 microfarad, 450 volts. That's perfectly fine. Let's hook a negative up to it and a positive, and let's see what our out of frame capacitor tester has to say about it. Let's see. First, let's check it for capacitance and put it into electrolytic capacitor mode there, like it should be. We ain't got no capacitance. Leakage. Wow, it's leaking at 50 volts. Yeah, that cap's toast. I do have some electrolytics in my junk box. Let's see if I have something analogous to that. 450 volts, 8 microfarad. That would function in place of that, okay, I do believe. Alright, let's just clip the old cap out without any mercy or remorse. Tack the new one in with a similar lack of care. It just has to be good enough that it's not going to fall off. Probably should have tested that cap before installing it. Well, it's not fully installed yet, so no one says I can't test it right now. Let's just check capacitance. Yeah, she's got a good eye opening. She's got capacitance. Let's test her at full rated leakage. It's not as ruined as the one that was there, so let's just buzz it in and see if that gets us where we want to be. We're going full Shango on this. Just do it the crappiest way that will possibly allow it to function. Okay, kick the camera. That's good practice there, Tom. You just kick that camera right on down the road. Sweet. It's doing halfway decent vertical deflection without any of the hacky heater voltage signals to places. Now we have 372 volts at that location. What's the plate of the vertical oscillator telling us? 305 volts. Yeah, that's sure seeming to be better. That's a nice sound. So I wonder what the grid looks like on that. Well, before we check the grid is negative 49 volts, which may or may not be alright. Can we find the voltage chart? What tube is that? V15 voltage chart is here. 125 volts, negative 37. Okay, that might be doing what it should be doing. Might not be doing what it should be doing. So I have my suspicions that we may have issues with the 50 microfarad cap on the vertical linearity C3D. Ooh, it's in 3 dimensions. What pin is that on? It's on pin 8, it appears. Pin 8 is U. So it doesn't seem like it caught fire while I was away. I think I know where channel 13 is supposed to be on this tuner. Actually seems like we might have some life in the tuner. I don't know about the rest of the set, but it would help if I had an antenna hooked up, and it would help if my antenna wasn't trying to hang on to everything other than the TV set. Sounds almost like there might be something going on. Oh hey, that's... I don't know if you can pick it up on the camera, but I'm definitely seeing traces of video. I love it when the fine-tuning mechanism is corroded into place. Yeah, tuner cleaner. I should be using expensive tuner cleaner and not WD-40. I'm an idiot. Yeah, that's definitely... Okay, so we got something. Where is the adjustment for the horizontal oscillator? I think I know where it is. Does it say anything about horizontal frequency is adjustment B1? Is B1 above chassis or under chassis? Sam says it's above chassis. Okay, that's good. Now I need a mirror so I have a prayer of seeing what I'm adjusting. Okay, control centered, and I adjusted the frequency on the horizontal. Okay, so I think both of the deflection oscillators are capable of running at the right frequency right now, but we have no sync signal to either of them because, well, capacitors. The answer to all a vintage TV life's problems is capacitors and troubleshooting. And wait, there are more answers. Am I even filming? Yeah, I am filming. Okay, I guess since I'm here, I'll show you what I have messed with to get to this point. So I changed that capacitor right there, that capacitor right there, this and this. I also changed this guy right here, and then my vertical magically popped back in. Horizontal hold control couldn't get me a frequency close to locked, so I adjusted B1, this slug right here, which is on top of the chassis right here on this big can. That's where we're at. Where are we going? This sync separator guy right here, he's a prime suspect. It'd be nice if his entire circuit was on one page. There's his other half and part of the horizontal circuit. So those are the things I need to focus on next. What we're going to try next is, according to the SAMs, it's capacitor C81. It couples the plate of the sync separator tube to the vertical integrator, which is basically a filter that separates the vertical sync out from the horizontal sync. What we're going to do is we're going to check that capacitor for leakage, because if it's pulling the plate voltage on the sync separator down, that's not good. So we're on paper capacitor mode. It's supposed to be at 0.01, so and it's measuring up around 0.15 to 0.2, which definitely is prelude to it's about to be leaky, and it is very, very leaky. Okay, that's good enough for me to say that that cap needs to go. Bye-bye. Let's just scrape some wax off so we can read what voltage this is. It's a 400 volt unit, so I have to fish out a 0.01 400 volt or higher from my junk box. This one doesn't have a voltage rating on it. That's not useful. 0.01 400. Perfect. This guy could work if it's not bad. Okay, that cap's happy. It will be good enough. That's all that matters. We're going to clip the old cap out and preserve as much of its lead as we can. And we're going to tack solder our new cap in very haphazardly. This is not a restoration or a set I care about again, so we are doing the absolute bare minimum to give it a chance of functioning again. If I'm lucky, someone will like this thing just enough to pay me good money for it. Good enough money for it for me to be able to say this time I'm wasting right now is worth it. I am actually bothering to take old cut off chunks of component lead from other parts that are laying randomly haphazardly on my workbench and using that to make an obnoxious J-hook clutch to hold this thing together. I'm going to give you a quick look at what we did here. We replaced this cap right here. Let's see if that gets us back our sink. We're on. So horizontal is practically in sync but floating. Vertical frequency is off. We definitely don't have sync yet, but I think it's slightly better. We have some semblance of something. What I'm going to go after is the cathode C90 capacitor, a 0.47 on the sync amplifier, and see if that gets us anywhere. That's probably this guy here, which is a 200 volt cap. Yeah, you're it. So we got this 400 volt cap that's the same capacitance as it, all lined up in case it's bad. Let's just get our soldering iron on the terminal and try to... There you go. That gets that loose. Let's hook our capacitor tester up. Good old Iaf C3. Let's see what C3 has to say about it. Is C3 PO'd? Okay, capacitance actually tests reasonable. How about leakage? It's charging up to opening at 150 volt, but it still has a pretty noticeable amount of leakage. What about 250 volt? Anybody home? It's trying. Awful, but it's trying. We'll change it anyway. We have a junk cap that we can swap it for anyway, so let's just get this thing out of here. So we've replaced that one capacitor, and we were able to get horizontal sync to be able to lock. It's not great, but we have horizontal sync. Vertical sync is still not there, so we need to next rebuild the capacitors in the vertical integrator, which would be this cap, this cap, this cap, and that cap. I haven't changed any of those yet, and those are probably muting the vertical synchronization signal a little bit. C85 is very leaky and off capacitance. I'm going to check C84 next. I'm going to replace C85 right now and do the two as a pair since they share a terminal. Can you see my capacitor tester? Yeah, you can. We're in leakage test mode for 25, actually 50 volts, and 150 it gets that bad where it's barely opening the eye. 250 it doesn't open the eye at all. Capacitance, the eye is supposed to open and it's only like halfway opening, so that cap it's toast. Put some butter on it, it's toast. So how's the replacement cap test? Replacement cap is fine. We'll just start buzzing the replacement cap in before we even finish taking the old cap out, because why not? That's in there. So that's a 600 volt cap for some reason. Why? Well, I have one. Maybe I should check the old one before I replace it. That would provide some entertainment value and some educational value. Let's do that. So the old cap is right there. First check it for capacitance. Barely any eye opening, so that cap is really bad. Leakage, it's also not performing too hot. Definitely needs to go. It's not as shot as the Bumblebee that was in the 0.1 position, but it's not great. Tag these in as crudely as we can get away with. You know what? Fine. You're good enough. Just get on like that. Good enough. Solder it. Let's just... I'm gonna clip the old one out. I'm not even going to bother to desolder it properly. I don't care. It's after midnight. I just want a nice, stable, synchronized picture so I can go to bed knowing that all I have to do tomorrow is figure out why there's no audio. A few days have passed. I've had to hold off on completing this resurrection because some changes were made to the household utilities, and we had an upgrade on the modem that's used to give us our landline phone. I was worried that we would lose pulse dialing capability that makes old rotary dial telephones tick. And a guy's got quite a few rotary dial telephones in his collection, and some of them I've bought and never tested over the last 3 or 4 years, and some of them I've had and wanted to fix to test, and I ended up just doing all of my rotary phones that have been sitting around all at once in the course of about 4 hours or so before switching out the service to the modem that confirmed my fears to an extent. It turns out the new modem does support pulse dialing, but very poorly. So that's been a huge disruptive, life-wasting, time-wasting pain in the ass. And I'll have to give you guys a sample of some of the stuff I learned while messing around with rotary phones in a serious capacity for the first time since I was a teenager. Yeah, it's been well over a decade since I last was seriously taking apart rotary phones. Anywho's, let's get this CTC-47 cranking. It's been off for a few days, so let's just start it off at 40 volts on the Variac and crank it up and see what it'll give us in terms of operation today. Do we still have raster? Did we get back the video signal from the RF that we had lost previously? Let's find out. How do I not? Oh, that would explain why there's no current draw if the thing's not plugged in. Hey-oo. 20 watts of power consumption and dropping. We'll let it continue to drop itself. Continue drop kicking yourself, Mr. Television. Odds are the rest of this video file is just going to be me variacing this television set, and there isn't going to be anything interesting to use for editing and for video making material, but let's just roll on a little bit. I wonder how much of the shot I'm blocking doing this. I'm just going to try to gently persuade it to climb back up to a good operational voltage and good operational status, and if we can get it to relight its screen and work okay, we'll do what we can to get a stable-ish, well-synchronized picture on it, and if that is able to be achieved, we'll play with some capacitors in the audio stages and see if we can talk this thing into supplying us with some audio for our listening displeasure. We have raster, so that's definitely raster. Boy, it sounds like we have channel 2 somewhat coming through, but I don't see it. Now, I want to know if we got any kind of signalage coming through, so let's just hook a test pattern generator up and see if we can force anything through on channel 3 since it's not getting our channel 13 generator. Sounds really good. Why don't we have any? I mean, we've got traces of video, but not nearly sufficient video. So why are we not picking up channel 13's modulator? Sure looks like there's hints of my test pattern generator. So I don't think my test pattern generator on that one is helping much. Let's try doing some Iaf injection with the old B&K 1077 analyst. Let's just pop this over IF mode. Now I need a service mirror so I can see the screen while I'm adjusting. Okay. Well, we have faint hints of video. Interesting sounds being demodulated by the audio stage. So I'm going to say that I want to next replace the 0.47 microfarad cap C80 in the cathode circuit of the sync amplifier and see if that does anything for us. We seem to have enough sync signal kind of make the vertical lock. Okay, we're going to replace the badly drifted 0.022 cap with 2.01s in parallel. When you put caps in parallel, the capacitance adds, so this will be a 0.02 cap and it'll be close enough. So we're doing this as a junk box resurrection here. We're just going to use the crappiest caps we actually have. I can't find a 0.022 in my box, and I don't really care. This cap hooks to there, and then it grounds there. Today on weird bullshit that RCA chose to do. Although they do extend that terminal to other places by wires, so yeah, I could tack it in between this point and that ground and that'll work. Oh, before I jam this sucker in here, let's just make sure it's not leaking. No leakage. Is capacitance in the right ballpark? How are you not reading capacitance, you sucker? Yeah, capacitance is fine. Now bear in mind, this isn't how I normally restore sets. This is how I work on sets that I would probably normally dispose of as cheaply as possible and never put any work into. This isn't going to be super fancy or super high quality. The goal here is to have parts in the junk box that I wouldn't use on a normal restoration and need to use up. Make this set work well enough that if someone tries to buy this off of me, they have a really good starting point. So we went after that cap. Let's turn it on at 50 volts. crank her up slowly to operating voltage. Say about 112 is about where we want to run it right now. At some point I may get courageous and give it a full 115 volts, or maybe even 117, but no more than that. Oh, duh! Yeah, plug it back in, Tom, so that it works. I've got dial lights staring me right in the face to explain why it's not powering up, and I'm not paying enough attention to see them. Holy. Something just arced around the width pot? Yeah. I think we might have tin whiskers in our width pot. That's good. Okay, so let's hook our B&K analyst back up and so it's ticking me off that I can barely get any video signal into this thing. So I'm about to try some slightly nutty measures. What we're going to do is we're going to hook the B&K analyst up and we're going to try to inject video in past the detector and see if our problem is Iaf related or if it's video amp related. We very well could have failing capacitors in the video amplifier circuitry. Looks like pin 7 of the 6AL5? Yeah, pin 7 of the 6AL5. Where's the 6AL5? You're him. Okay. 7 should be essentially that coil in there that's hard to get at, but this is close to it. Okay. So if we inject some video in here at maximum gain, we do get some... Yeah, that's not bad for video injection. Let me play with the width control since I had messed with it before. Okay, so brightness. Got some brightness. That's with contrast at maximum. That's pretty lousy. We're using the full output of the B&K analyst to drive this thing, and that's about all we can get at full output. We shouldn't, at the output of the video detector, be getting that little signal, I don't think. Let me probe a couple other places. So we have a 12AU7 video amplifier. That essentially was feeding into the grid of that tube. Let's clip into the grid of the second video amplifier stage. That would be pin 7 of the 12AU7, which is this guy here. I think you're 7. Yeah, you're pin 7. Why is that so anemic? Should be a lot more. Okay, so if I inject directly here at this side of the capacitor, video's okay, but if I inject on the other side of the capacitor, I get nothing on the grid side of the capacitor. Something tells me that capacitor might be bad. Let's just go after it. Because I should be able to get the same level of signal on both the plate and the grid side of the capacitor doing video injection. I'm not, and I don't like that. I like that one bit. Now, let's just capacitor, and let's see here, it's supposed to be a 0.1. Eye opening's a little bit high and not full on capacitance. It's got leakage at 150 volts. And this is a 400 volt rated. Okay, so I checked the new cap I'm going to use to replace it with. And we're going to do this maximum cheap and maximum sloppy. That's a better solder joint. Drip solder into places that it probably shouldn't be dripped. Just hope we didn't short anything out doing that. Okay. I have no idea if I'm still filming or not. I'm gonna hook the video injection up to the grid of the first video amplifier tube. Power this thing up and let's see. Okay, video amplifier polarity is reversed. I don't know if that did anything. Well, I'm not pulling that cap back out to find out. What other caps do we have in here that might be a problem? We got a .0015 cathode bypass cap on the video output tube. Oh, I should check something while I'm here. I got a multimeter. Let's check a voltage. So there's a multimeter that doesn't want to stay where it should be. There's a cap that feeds the plate of the first video amplifier tube. Not quite feeds it, but filters the B+ signal going to it. And that cap is a 5 microfarad, similar to the one that was dragging down the vertical. Let's see if I can check plate voltage. That would be on pin 1. Only 53 volts. That seems really low. The B+ feeding it is 98. Should that B+ rail that's feeding it be 98 volts? That sure seems low. There's a 200 volt source that feeds it for a 6.8K resistor. So you're the 6.8K resistor. There's a lot of voltage drop. The resistor's not getting very hot. The 210, the 200 volt B+ is 170. It feeds into the resistor, 172. That's not terrible. It's not great, but it's not terrible. I am running at reduced line voltage, so let's check the voltage chart. Pin 1 of V8. You didn't know your V8 had a pin 1, did you? Should be 100 volts DC. So did we improve plate voltage any? Still pretty low. We're going to try unhooking the filter capacitor. Feeds that C1D. Let's try unhooking that filter capacitor and see what it does to plate voltage on the first video amplifier. So when you're only getting about half the plate voltage you're supposed to be getting, that's going to reduce performance of the stage a bit. Let's see here. Do I have something? Oh, yeah, this used spray atom, 4 microfarad. That'll definitely do something. I'm just gonna tack it in crudely as humanly human. Oh, come on now. Melt the joint well enough that I can get a solder joint on there. And we're just gonna rudely tack this in. Let's power this thing back up and see what it does. Oh, I see. So the plate voltage is actually dependent upon the contrast setting. So basically we're running that tube really hard to get a lot of contrast out of it. That's interesting. Wonder if the tube's just bad. We got two 12AU7s on this thing. Let's just swap them and see how it reacts. I'm going to do a hot swap. Sort of like a hot take, but swappier. I don't know. What's the plate voltage like on this? It's even lower, but we have slightly more gain, it would seem. Supposedly this thing has variable DC restoration somehow. Is that this back switch? That doesn't do a lot, and I guess I'm fine with it not doing a lot. So I guess we've established sync separator activity is fine because we can feed video in and get good sync. We verified that it would seem we're probably not getting very good signal in from the video IF system. So I think I might have found what's the matter with the video IF stages. The screen grid of the V5 video amplifier tube has this nice 0.1 microfarad 600 volt bumblebee capacitor on it. The cap is lightly warm. The screen grid measures 80 volts and its supply measures 174 volts. And it should measure higher than 80 volts according to our voltage chart. I'm going to guess that this bumblebee capacitor is causing us some problems, so it makes lots of sense. The bumblebees often are worse than the actual wax paper caps that they were supposed to be an improvement on. I mean, they are wax paper caps themselves, but they are even worse than regular paper shelled wax paper caps. Let's just check capacitance here. Capacitance eye opening isn't bad. How's leakage? It's pretty bad at 50 volts. It's really bad at 150 volts. And it just gets worse on down the line, and it's supposed to be a 600 volt cap. So yeah, we got problems. That cap suicided on us. Not surprising. What do we have for a placement? Yeah, it tests fine on capacitance. It's pretty ugly, but it'll work. This isn't a beauty contest. This is a functionality contest. This bumblebee just lost. Let's see if this bumblebee gets us back our video. Okay, that cap's in. Let's power this up again and see if we can get ourselves some video IF action going again. Okay, screen's lit. Let's hook some signal up into this thing. There's a tiny bit of signal in the video IF. Yeah. Looks like getting no satisfaction out of this thing. What is that voltage at? Holy crap. So, I think I might have fixed the problem with no signal getting through the video IF. Notice that I haven't connected the signal generator up to the antenna input yet, and it's actually picking it up. Wow. Yeah. Okay. That's pretty much exactly what I was hoping for, and then some. Let's increase RF attenuation some, and let's try for, hey, it's coming in on channel 2, coming in hot. Sweet. I think we're back in business. Let me see if I can get my channel 13 agile modulator. Ha! Yes! So I'll explain to you guys what was wrong and what I found, and ignore the multipath reception on the antenna skewing the sync. So this little capacitor right in here is very leaky. This paper. I just unhooked the grounded end that goes to here. That capacitor I'm pretty sure is C50. I'm pretty sure is C52 that filters the screen grid to the fourth and final video IF tube. That capacitor, by being basically shorted to ground, was basically eating up all of our signal. Busted off of there so that the old cap's gone. Now I do not have to think about it. Let me try to move the antenna so we have a slightly less bad signal. Yeah, there we go. Sweet, now we actually have a nice stable test pattern. Let's see if we can get the vertical to look a little bit better. Okay, so the vertical is a vertical linearity issue. That's in the cathode circuit, so that 50 microfarad lytic in the cathode's probably bad. Yeah, I'm gonna change it. I can even probably demonstrate that it's bad through stupid and dangerous practices. That sounds entertaining. Now that we have good signal coming in through the video IF and we have stable sync and all that jazz, let's hook a capacitor in parallel with the vertical output cathode capacitor, which connects to pin 8 of the vertical output tube. Vertical output tube, I believe, is that guy. And I think I see pin 8. Does that do anything? It does a little bit. Could be the old capacitor that's installed in there isn't any good. Maybe I'll try changing that out. But before we do that, since we have a pretty reasonable picture right now, let's see if we can get some audio through this thing. I've got no audio on my test pattern generator right now, so let me run my cell phone over to an audio input on it. Okay, we have really faint audio that's way off on the fine tuning from where the best channel reception is. Yeah, I can barely hear it, but it's there. So my question, well, obviously we have some Iaf alignment issues, but one of my questions right now is, how good's the audio amplifier on this TV? We're going to do something mildly dangerous and somewhat silly, and let's hook up our cell phone to the phonograph amplifier input on the back and see. Okay, so the audio amplifier circuitry on this TV is right as rain. So it's the audio Iaf amplifiers that are not quite right on this thing, and that makes all the sense that it needs to make. Yeah, so we've got a little bit of audio coming through. Let me see if I can improve that. So this is forcing sound Iaf signal injection into the first Iaf amplifier into the first sound Iaf amplifier of this set. Actually, there's only one sound Iaf amplifier, so it doesn't matter if it's the first or second. It's the only. So that's injecting sound at the grid, and that tells us that we do in fact have a decent amount of sound Iaf amplifier gain. It just sounds like the sound Iaf isn't tuned up properly. I'm sure some people are going to complain that I'm screwdriver drifting the audio Iaf on this set, but I don't really care. Instead of raw dogging it, you use a real Iaf tweaker tool. I love it when my tweaker tool tips are as sharp as hammers on the screwdriver portions. It just really makes this easy. Here's a better one. Come on, next song.
What I'm doing in this segment is a process some TV collectors do on split sound sets that have audio alignment issues, a process called walking the audio Iaf. Basically, when best audio and best picture don't line up on the fine tuning control and are off by an intolerable amount, to cure that, you walk the audio Iaf by essentially fine-tuning to the point of best audio, then adjusting the fine-tuning as close to the point of best video as you can get without completely losing the audio signal. Then you adjust the audio Iaf system on the television to provide maximum audio gain at that point on the fine-tuning control. Once you've got maximum audio gain at that point, you then walk the fine-tuning control closer to the point of perfect picture, and you adjust the audio again for best audio response. If you do this right, you can get it so that the best picture and best sound line up.
Oh, so that's also like a sound coil, isn't it? What's the sound alignment procedure look like? No alignment procedures? Oh, come on, people who scan Sam's photo facts. You gotta scan the alignment procedure. Oh, there it is. Just skipped over it. A3, 1, and 2. Reaching the point where I'm gonna make this thing work one way or another. So I think I might know why I can't get the sound IF to tune up. Another collector who's worked on these sets out in these parts told me that these two capacitors right here, they're actually through chassis capacitors, and they appear on top of the chassis next to this ratio detector FM audio IF can. The voltage on this 12K resistor, this one cap, it's the voltage is 100 something, actually not quite 100 something, it's 95, which is reasonable. On this side the voltage is 59, so this cap here is leaky. I've been told those caps get leaky, and now I see. Those are the screen filtering caps, and they are 1,500 picofarad. I'm going to clip out the bad one and see what I can find that's close that I can tack in. Okay. Okay, now that the camera battery's charged, I can film again. We got faint audio, enough to say that it's got audio. We've got picture. These are the caps we changed out in the course of getting it to this point. Only one lytic, and some of the paper caps we changed out, it might have actually worked this way with. And we also changed that cap and that resistor there. The main problem with the audio being incapable of being tuned anywhere close to jiving with picture and still having any signal strength was the 6AU6 is bad. I swapped a different one in with substitution and got significant increase in audio gain, and was able to tune up the audio IF alignment to kind of jive with picture. There's still not a lot of strength in the audio, but it's good enough to demonstrate that the set has some audio. Also, there's an audio input on the back for a phonograph, which we can use to demonstrate. There's one last thing I want to do with this set before we put it back in its cabinet. There's actually two things we need to do. One is related to the electronics, the other is related to the cabinet itself. So, the set had inside it this assemblage. This is supposed to plug into a connector near the high voltage cage, and this end is supposed to connect somehow to the metal bell of the picture tube. To be bluntly honest, I can't find where this thing is supposed to connect. It looks like someone cut this wire and just crudely crimped this lug connector onto it, and whatever the original scheme was for connecting this seems to be long gone inside the set. So what I'm going to do is I'm going to take the crappiest piece of high voltage lead I've got that's of sufficient length, and I'm going to put a alligator clip lead on one end so that I can clip onto the spot where I have the temporary extension wire clipped into on the picture tube, and hardwire the other end into the high voltage cage. It's not a great solution, but whoever did this didn't exactly come up with a great solution either. So, also, what looks like a TV in there next to the green television, that gray cased thing, is actually a telematic test jig for monochrome televisions. It's got an 8XP4 picture tube in it, a deflection yoke, some adapters for different monochrome picture tube bases, and a speaker and audio output transformer. My problem with that test jig is that one of the God knows how many previous owners of it lost the high voltage extension lead for it, so in certain cases where a television chassis doesn't have a long enough high voltage lead to reach into the cabinet and connect to the picture tube, using that is very difficult. So I'm going to steal the HV connector on the high voltage cage of the CTC-47. It's the same style connector as what's on the side of a picture tube. I'm going to steal that connector, and I'm going to use that as half of an extension lead for that test jig. That's two reasons for me to change the high voltage wiring on this TV. Okay, so I got this as the high voltage lead. That's super safe, but it's not any worse than really what it came with anyway. 44.6 ohms, 31.5 millihenries. This is the inductor value of the horizontal winding of the yoke. This is for future note on this KCS-47 chassis because somewhere, I think that little RCA box next to the cassette deck has a couple of replacement flybacks that I believe fit this set that I'm thinking about someday making a plasma speaker with. We'll see if that ever comes to pass. I'm going to try to get the whole shebang fitted back into the cabinet and hooked up properly. Give it a quick test run and take some pictures to show the world that this set is a reasonable starting point for a restoration, and thus improve its limited marketability to TV collectors slightly. I made that nice and messy, didn't I? Doesn't matter. Get in your home and clean your sloppy Joe. Before Sloppy Joe claims you. And there you can see our sketchy little HV wire hooking on to one of the metal fingers in the mask that touches the bell of the tube, which is also metal and is supposed to be at high voltage. Just rewrap our little yoke grounding strap. Well, you're supposed to get in that little hole there so that I can do that to you. There. Grounding strap connected. Work. Let's just put you on the tripod. Let's just start whacking this thing back together as quick as we can. Quick, assemble it before it breaks again. Can do. I'm sure finger-tight chassis bolts will get this set to the ETF in one piece, no problem. It's only about 400 miles banging around in a Suburban. The picture tube's metals, and there's a safety glass, so when it implodes, it'll all stay in the cone. Okay, I think my patented vice grip fingers have done their job. Here's where the channel plate shot off to. Note to self, don't install the chassis with the tuning knob on when the channel plate is also on. Unpleasant things have been known to happen under that circumstance. There's no way it goes on like that. I mean, unless it somehow does. The magic of editing this will be suddenly assembled and you guys will have no clue what I did. I won't either. I clearly don't. Boy, I did good on finger tight when I can't even undo it by finger. So one neat feature I'll show you while I can is this center shaft on the contrast control. When you pull it out, it turns on the tuner dial lamp. When you push it in, it turns it off. It's a neat little design scheme so you don't have a distracting tuner dial lamp while you're trying to watch a TV program. Alright. Let's throw an antenna on this piece of hot garbage and give it one last run test. I can take a couple of test pattern holy pictures of this thing. So you can see the bottom indicator lamp's on. If I pull this out, the channel indicator comes on. If I push it back in, the channel indicator goes off. It's a neat little feature. Okay, let's do that. Now we have a nice test pattern. Let's turn the brightness down a little bit. Yeah. Okay. Obligatory test pattern holy pictures completed.
So while filming the ending, the top half of my tripod with my camera somersaulted off the tripod and fell to the concrete floor, and did that to the Nikon camera.
Well, that concludes my Nikon camera, I do believe.
So because the footage I filmed for the end of the video is gone, I'm going to piece something together here. Thanks for watching my video. If you enjoyed this, please leave a like, and consider subscribing to my channel for more content like this.